Right, so in this video we are going to focus our attention on chemistry, that is the periodic table, and we are going to use the paper that was given in the 2020 school certificate. Yeah, that is the ECZ paper. All right, so as the question says right there on the screen, we are given a list of elements in that small table there, right? It says to which the first one is lithium, beryllium, boron, carbon, nitrogen, um, oxygen, fluorine, and neon. All right. So the question here is being asked to say to which period of the periodic table do these elements belong. So you've been asked the period number to which these elements belong. Right. So just a reminder here, just a simple reminder. When you have we have these and we have these. These are the horizontal rows, then these are the vertical columns. So I'll indicate these using Y and these using X. So X represents the number of it represents the arrangement of the period. Y represents the arrangement of the groups. All right, so the horizontal rows, these are the periods. The vertical columns, these are the groups. All right, so when you check your periodic table, my periodic table that I'm using is this one right here. All right, so though it's not much clear, so we have lithium here, beryllium, the list goes on like that. So when you look at this, the period to which the period number to which these elements belong is period 2. All right, so answering question 1, which is A. All right, it's they belong to period 2. All right, so question B says what happens to the number of shells across the period shown above. All right, so now when you look at the shell, the question simply means when you write the electronic configuration of lithium, for example, and neon or oxygen, then try to look at the number of shells that each of them have when you write the electronic configuration. So here I'm going to use the first one and one of the last elements to see how the to see if there's any change or there's any increase or there's any reduction, or yeah. So what's going to happen here is that lithium has an atomic number of 3. Then I also use oxygen. Oxygen has an atomic number of 8. All right, 8 it is. Okay, so when you write the electronic configuration of lithium, what's going to happen is this: you're going to say 2 in the first shell, then 1 in the last shell, making a total of 3. All right, then for oxygen you're going to have 2 and 6, they are making 8. So when you look at lithium and oxygen, the number of shells has remained the same. 2 shells, 2 shells right there. Remember, the simple formula that helps you to determine the number of electrons that can be put in that particular shell is this: you have 2n to the power 2. Okay, so now how do we use this formula? How we use this formula is this. For example, you don't know the number of electrons that you can put in the first shell, and the first shell is represented by 1. So you're going to say 2, or you open the bracket, you put 1 here, you close like that. 1 to the power 2 is 1. 1 times 2, you're going to get 2. So meaning in the first shell you can put 2 electrons. In the second shell you can put 2, open bracket, 2 representing second shell, power 2. 2 power 2 is 4. Multiplied by 2, 8. So that is how that magic comes about. So the question to answer B is the number of shells remains the same. Okay, so now we go to C. So B, they remain the same. Number of shells remains the same. Then C, answer the following questions using only the elements shown in the table. Okay, each element can be used once, more than once, or not at all. So we have been given a list of 3 questions: question 1, 2, and 3. So now the first question says which 2 elements would form an ionic compound. All right, so when you're given a question to answer, it becomes easy for you to answer that question when you know what you're being asked about. So when the question is talking about an ionic compound, you ask yourself, what do they mean by an ionic compound? All right, so an ionic compound is one that is formed is simply a result of an ionic bond. And we know to say ionic bonding is a relationship between a non-metal and a metal. Right, then a molecular compound is one where it's a result of the relationship between a non-metal and a non-metal. So a metal and a non-metal, of which we say a metal is a cation, then the non-metal is an ion. When you put them together, that relationship, they give out an ionic compound. All right. So in this case, meaning you're going to pick a metal and a non-metal. So just knowing what it means by an ionic compound, you have already made your work simple. Instead of saying, what do they mean? You start guessing this and that. No, by knowing what the question is asking about, by understanding where it is coming from, by understanding what the question means, you have already made your work simple. All right. So here I'll just simply use the same one that I've already used as an example. So remember to say oxygen is a diatomic. So what you're going to have as a result there, if it's 1, meaning I'm picking lithium and oxygen. And when you put these two together, what you're going to have is lithium 2 oxide, like that. All right, then question 2 says, which element has a valency of 3? Okay, wow, very interesting. So when talking about the valence of 3, in another ways, it's more like the combining power. So it's just a matter of you going to the periodic table, look at the number of outermost electrons in the outermost energy level, or the outermost shell that you have. Then that's the one that's going to tell you, that's the one that is going to alert you to say, okay, now this one has a valency of 3. So you just go to the same list that you have been given. So if you look at if you look at the first one, lithium has a valence of 1, beryllium has a valence of 2 due to its group. Then boron has a valence of boron has a valence of 3. When you look at the atomic number of boron, it's 5. So that 5, we say 5, we subtract it from 8. What you're going to have is 3. Right. Then you look at group 6. That one in group 6 is going to give you that one in group in group 4 there, carbon is going to give you it will have a valence of it remain as for itself. So the valence is simply gotten from the number of outermost electrons that you have. All right, so going to the last question, which says, which element has allotropes? So now again, here comes the different situation. It's the same situation as the one where we're being asked to name the elements which would form an ionic compound. So now the question is, what are allotropes? All right. Okay, so now when talking about allotropes, one thing that you need to put in mind is this. When you're talking about allotropes, for example, say allotrope of such and such and such a compound, talking about that compound existing, or that element existing in 2 or more forms. All right, it can be in a soft form, it can be in a hard form. So the well-known the well-known element that has allotropes among those that we have been given the list there is carbon, and the allotropes of carbon, we have graphite and diamond. All right, so that's how we go about that question. Yeah, so question 3, we say it's carbon. It's the one that has allotropes, so meaning it can exist as graphite or diamond. All right,